want to talk about ANOVA still, as we've discussed from the previous video. And now, one thing you should know about ANOVA is you are checking to know if there is no significant difference. That's when P is greater than 0.05. You are also checking if there is a significant difference. That's when P is less than 0.05. Now, if there is a significant difference, at that point you might want to know which sample or samples is different from each other. That's when we'll go on to run the supplementary test, the one we call post-hoc. Post-hoc, we now carry out this test to investigate differences between the samples. Between the samples, very, very important. Also note that the post-hoc test can only be performed on 3 groups of data and above. So when you're dealing with data, there are less than maybe 1, 2, there are less than 3, your post-hoc test cannot be run. Take note of that. So I'm going straight to what we have today. Now, let's say you are a scientist, and I have my variable view here, just like I pointed out to us the other time. The variable view have my group here, and under my values I've already defined what the values are. If you click here, you notice something. Maybe as a science student, you have some experimental animals. You got an extract, and you want to feed them with this extract for some time, and then after which you observe their weight, to know if there is actually a difference in their weight. So this group 1 is my normal. These ones were given the normal feeds and without the extract. Then your group 2 were given 20 milligram per body weight. Then 350 milligram, 100 milligram, 150 milligram, 200 milligram, 200 milligram, and then we have 250 milligram for the group 7 rats. So these are now my weight. Weight is measured in pounds. So after doing all those things, I actually took the weight. And also take note that the ones that we gave this milligram of the sample, they were also given the normal feeds. They're also given the normal feeds. So after we'll be comparing these with the normal to see if there was a significant difference. So okay, so we'll go back to our data view. Under data view now, you notice something. Our grouping, this is group 1, where we'll have 3 samples. 3 samples. Just like I explained, like if you want to do anything post-hoc or any other thing, talking about comparison, you must have at least 3 groups with 3 samples. So we have group 1, we have group 2, we have group 3, we have group 4, we have group 5, group 6, and then group 7. Now these are the weights that have been generated. These 3 samples means 3 rats. Yes, 3 rats that were evaluated, to know their weight after the experiment. This for the normal, and this is the ones taking 20 milligram, the ones taking 50 milligram, and the rest. All right. So now, what do? We go straight. First and foremost, you analyze, and then you go to compare means, and you go to ANOVA. One-way ANOVA. You can clear whatever you've done here before, reset whatever you've done here before, and then we'll take our group to our factor, and we'll take our weight in pounds to our dependent list, and you run your ANOVA. Now, having run our ANOVA, our focus is here under the significance. This is between groups and within groups. So the overall significance of what we've done here is 0.063. So merely looking at this value as we run the ANOVA, we can see that over here there is no significant difference because this value is a bit higher than 0.05, which is our level of significance. So as a statistician, there's no need of going to run the the post-hoc. Yeah, you only run the post-hoc. That's the Turkey comparison when we're actually seeing a significant difference between the groups and within the groups. So you just want to do it for doing sake, but ideally you should stop here and just conclude on whatever you're doing. Maybe go back and take your descriptive analysis to get your mean and standard deviation, and that's all. But there are cases where there is a level of significance. If there's a level of significance, that's for your p-values less than 0.05, or 0.05. So we can go on to run the post-hoc test. So let's take a view of a different scenario. All right. So here we are with different set of values. I'll just alter them so that we can get a better understanding of what we're trying to explain here about statistical differences among our values. Now, when we go to analyze now, we go to compare means, and we go to one-way ANOVA. Let's reset whatever we've done before, and we'll go to group as our factor, this as our dependent list. Now we say okay, now come over to significance. See here 0.008. It is far lower than our level of significance, which was set at 0.05. So when you see this kind of value in terms of significance, it is here you can now go on to run your post-hoc Turkey test. So let's just head on to our post-hoc, go to analyze, go to our compare means, and then you go to your one-way ANOVA, go to your post-hoc, and then you pick your Turkey, and we have other ones here like your donuts and your Duncan. So we're focusing on Turkey now. You now say continue, and then you run your analysis. Now having run your analysis, let's expand this. You now come over here, and then you see that indeed there was some level of significance when you look at when you are comparing the mean differences. This column, or you take note of, when you come over here, it reads that the mean difference is significant at the 0.05 level. That's when you have the asterisk. So let's come over here. When you are comparing the normal with the other groups that were given different doses, if you are comparing their mean difference, the mean difference in their body size, their body mass, that's pounds, you see that there's no significant difference here when you are comparing the normal with other groups. But when you come over to your 20 milligram, the group of experimental animals given the 20 milligram, you see that there was a significant difference when you're comparing the 20 milligram group with the 100 milligram group. You see this asterisk here tells you there's a significant difference, and without being told, you should know that your significance level will be lower than 0.05. see, already set at 0.01. the rest are higher. So that's, look at the asterisk. So if you check out to see where you have the asterisk, you observe that the level of significance will be lower than 0.05. There's a case also here where you're comparing the 250 milligram group. When you compare them with other groups, you see that there's also a level of significance here where you have the asterisk. You're seeing 0.009, which is far lower than 0.05. So this is how we use our ANOVA, the post-hoc test, to compare, do a multiple comparison, within the group. So this is what we mean. Yeah. So that's it. Thank you.